Geometric and arithmetic, very good. Those are our two main types. Which one you want to write first? Geometric. I heard it louder. Okay, arithmetic. Geometric is what type of function? It's an exponential function, yep. So I'm going to write that in the how to identify. It's an exponential function. Also, you can identify by looking for if there's a number that's being multiplied each time. That would be called a common ratio. Common ratio. The explicit rule. Explicit rule is basically just the function rule. I don't know why they're called explicit. It makes them sound like they're bad, but it's just the regular function rule. So remember, it starts with an, which is like a y equals. And you remember what it has then? A1. And then what do we do to the A1? Times r to the power of n minus 1. Good. Geometric did have two sum formulas also. It had like a terminating sum, a partial sum, and it had infinite sum, two sum formulas. So I'm going to put a little line down the middle. For a partial sum, that sum formula started with A1, and then it has a big giant fraction, 1 minus r to the power of n over 1 minus r. Good. Okay, and then we also had a infinite sum formula. The infinite sum formula was a whole lot easier. And you remember what was on the top of it? N over 2.
Oh, the ratio over something over 2.
Nothing over 2.
What? There's probably a ratio.
Feel free to flip back in our notes. Y'all need to make some flashcards. A1 is on top.
Over 1 minus r.
Over 1 minus r, right. And we can only use this if the absolute value of r is what? Less than 1. If r is less than 1. If r is greater than or equal to 1, you can just say it diverges, there's no sum, etc. Alright, arithmetic. This is the one. What type of function would it represent? A linear function. Good. It's a linear function. You can also look for it based on a common difference, basically a number that's been added or subtracted each time. Common difference. Okay. It's explicit rule, or it's function rule. Again, it starts with an because it's like a y equals. What did it have at the beginning? A1 plus n minus 1 in parentheses, good, times the common difference. Perfect. And then this one's sum formula. This one only had a partial sum. If you ever see arithmetic and it's infinite, you would just say no sum. So partial sum formula, n over 2. Now comes your n over 2. N over 2, and then there was something in parentheses.
N over 2 and 1 minus n
A1 plus AN, right. Starting term plus ending term, right. Good job. Okay, so that's like 1, 2, 3, 4, 5 flashcards. I think we can do that, Danny. All right, today we're going to look at a different way to write the rule. So what we've done so far have been what are called explicit rules, where we're writing them as a function. An explicit rule, remember, is a rule where you can actually plug in the term number that you need. If you need the 50th term, you plug in 50. If you need the 75th term, you plug in 75. But now we're going to look at recursive formulas. A recursive formula, you cannot just plug in the term number that you're looking for. In a recursive formula, each term is defined as a function of its preceding term or preceding terms. So basically, each term is found by doing something to the term immediately in front of the one you're looking for. I know it sounds weird, but let's look at it. So for a recursive rule, there's two parts of a recursive rule. They're going to tell you what number to start with, and they're going to tell you how to find more terms. Okay, so if I need to find the first 4 terms of this sequence, I'm just going to write out first 4 terms. Okay, I'm basically told what the first term is. The first term is -2. Okay, now let's pay attention to how it's saying to find more terms. So what this means right here, this means to find any term in your sequence, you take the one right before it and you add 3. That's what that little an-1 means. That means take the one before it, the number before it, before the one you're looking for. If we're looking for this one, we look at the number before it.
Oh.
I know, it's rocket science. Take the number before it and add 3. Okay, so if I'm looking for this term right here, I'm going to take the number before it and I'm going to add 3 to get 1. If I'm looking for the third number, I'm going to take the number before it and I'm going to add 3. If I'm looking for the fourth number, I'm going to take the number before it and add 3. Don't listen to him. Okay, that's it. It's not bad, right? Okay. All right, looking at the next one. Again, we're asked to find the first 4 terms. So breaking it down, we're told the first term is 2. Any term after that says we're going to do 3 times the number before it and then add 4. 3 times the number before it and add 4. So again, we're finding 4 terms of it. We're going to start with 2. To find the second term, I'm going to do 3 times the number before this one. So 3 times 2. And then I'm going to add 4, which gives me 10. To find the third term, we're going to do 3 times the number right before this one. And then add the 4, which is 34. Very good. Okay, and then to find the fourth term, we're going to take 3 times the number right before it, so 3 times 34, and then add 4. 106. Very good. Again, it's a cool way to write the rules, but it would be super annoying if you had to find like the 100th term, because you'd have to find 1 through 99. You can't just plug in 100, unlike an explicit formula where you can plug in 100. On the bottom, we are asked to write each recursive rule. Recursive rules have 2 things. You have to tell me the first number that you're starting with, and you have to tell me how do we find more numbers. The first number and how we find more numbers. So I definitely can see what the first term is. What's my first term? It's 1.
So the number before is 4.
So we're going to look through here, and what are we doing each time? Adding 4. Okay. So let's see. What we're going to say is we're going to say take the number right before it, which is just the an-1. And what do we do to the number right before it? Add 4. You don't have to put this in parentheses. I just think it looks a little cleaner in parentheses, although it's not required. Is this one technically arithmetic or is this one geometric? This one is arithmetic, yeah. Okay, for the second one, again, there's 2 things that you need to write a recursive rule. You need the first term, and you need to tell me what we're doing to find more terms. So looking through this, it looks like a multiply, so it looks like this would be geometric. Multiply by -1/6, yep. Remember, the way to do it is you can take any term and put it over the one right before it. So take -1, put it over the one right before it, that's -1/6.
Is it always going to be the one right before it?
Yes. All right, so we're going to start with writing our first term, which is 216. Okay, so to find more terms, remember we're going to put that notation that means take the number right before it. And what do we do to the number right before it to find more terms? multiply by negative 1, 6. Alright, before we flip it over, I'm going to just kind of show you another type of problem you might run into. So say we have an explicit formula, and that formula is AN equals, I'm just making stuff up, 27 minus 3N. Okay, it's fully simplified. Can we tell if this is arithmetic or geometric? How can we tell it's arithmetic? There's no exponent. It's a linear function, right? Okay. And say from this explicit form, you're asked to write the recursive formula. Write the recursive rule. Yeah, okay. So remember, there's two parts to a recursive rule. There is, what is the first term? And what are we doing to find more terms, right? How would we find the first term if we have the explicit formula? Plug in 1, yeah. A1 would be 27 minus 3 times 1. So what's A1? 24. Okay, so your A1 is 24. Okay, our AN, we can actually see from this explicit formula already how to find more terms. Take the term right before it and do what with it? Yep. Subtract 3. How do we know it's subtract 3?
Because it says negative 3.
Because that's the common difference. When you have an explicit formula, this is your common difference. So it's saying D is negative 3, meaning I know that to find more terms, I'm always just going to do minus 3, minus 3, minus 3, minus 3. Now we can flip it over. All right, back side. Advantages. What are the advantages of the recursive rules? Yeah, it's easy to find terms. Yeah, you just plus 3, plus 3, plus 3, plus 3. It's very quick to find terms. I kind of already mentioned the downside.
So you have to know the term before it.
Yes, you would always have to know the term before it. So like, if you need to know the 100th term, what else are you going to have to find?
99.
1 through 99. Because you can't just find the 99. You got to find the 98th, and then the 97th, and the 96th. So it would be annoying to find a large term number. All right. Word problem with recursive formulas. Says you have $10,000 bank account. That's nice. With 12% annual interest compounded monthly at the beginning of the month. You put in $500 once a month in the middle of the month. How much do you have in the account after half a year? Okay. This is technically a recursive rule. Let's think about what our A1 is. What's our A1? 10,000. Very good. Let's think about what we're doing to find more terms. Well, there's actually two things that we're doing.
10,000 times 12 times 0.12.
More.
Oh, plus 0.12 times. Wait.
12% interest and 500 once a month. Okay. Here's the problem. We can't just say we're multiplying it by 12% because we're earning that 12%, which means that 12% is already going to be put back in the account. How do we represent that?
Plus 12.
What? Someone said something over here?
Times 1.12.
1.12. 1.12 adds it back into the account. So 1.12 times the term right before it. And then what else are we doing?
Plus 500.
Plus 500. Okay, and we're trying to figure out how much is in the account after half a year, which means how many months? 6 months. 2, 3, 4, 5, 6. Month 1 we know is 10,000. Month 2,
11,200.
1.12 times my 10,000 plus the $500. This is going to make it 11,700. Good job. Okay, how do we find month 3? Yeah. 1.12 times 11,700 plus 500, 13,604 would be month 3. 1.12 times 13,604 plus 500. Next one's a decimal. I'm just going to round it to a whole number. What would be my closest whole number? 15,736.
Well, that's 48 cents. You don't want to take that part.
I mean, you want to write the decimal? We'll write the decimal. 0.48. Danny requests a decimal. I know, that makes the difference. Alright, 1.12 times that one. Plus 500. The next one has even crazier decimals. Let's round to money. So 18,124 and 86 cents. And then one last month. If you were actually doing the multiplication, you would know that.
Oh, I am, but like...
No, you're not. No, you're not. I can see you don't have anything in your hand. All you're doing is just writing down what we're writing down. There's the last one. I know, it's 12% is a lot. You're never going to find 12% in the real world. There we go. At the end of half a year, we'll have $20,799.84 in the account when we just started with $10,000. Alright, we have two weird functions here. Let's see if we can look at this first one. So, looking at it, it's 1, 1, 2, 3, 5, 8, 13. It is the Fibonacci thing. What is the Fibonacci?
Add the previous 2 numbers.
Add the previous 2 numbers. Very good. Danny said to get any term in the sequence, we add the previous 2 numbers. So, like, to get this 13, we added 5 and 8. To get 8, we added 3 and 5. What would the next number be?
21.
Good, etc., etc. So the trick is on this one, when you write your recursive rule, you can't just write the first number. If you only write the first number, you're not telling the person enough to be able to find more terms. What do we have to write out on this one? The first 2 numbers. You would need to specify what the first 2 are, and then what are you doing to find more? So I know the first one is 1. The second one is 1. And then to find more terms, how do we add the 2 before it? A-n minus 1 plus A-n minus 2. Very good. A-n minus 1, that would be the one right before it. Plus A-n minus 2, that would be the one that's 2 before it. And that would tell the person how to find more terms. Start with 1, the second number is 1, and then start adding those 2.
Oh, I know the next one as well.
Yeah, next one's very similar.
Multiplying the last 2 numbers.
Yeah, it's multiplying the 2 numbers right before it. So like to find this 8, you would multiply 2 and 4, the 2 numbers right before it. To find 32, you would multiply the 4 and the 8. So again, since it's involving having to use 2 numbers, you have to specify 2 numbers to start with. And then tell it what you're doing to find more numbers. What number do we start with? 1. And then 2. A-n minus 1 times A-n minus 2. Meaning, take the 1 right before it and multiply by the 1, 2 before it. Last section is kind of just a weird little synonym of a recursive rule. I guess I don't know if that's the word I would use. It's just a word that also means something that's very similar to recursive rule. It's talking about an iteration. Have y'all heard the word iteration not in math before? You heard it? It's kind of like just a different version. Iteration just means kind of a different version of something. But in math, it talks about the repeated composition of a function with itself. So this says to find the first three iterates. Find the first three iterates, which would be x1, x2, and x3 of the function given the initial value.
So the iterates are just the numbers in the function?
Kind of, yeah. So we're looking for x1, x2, and x3 when we know x0. And it's going to follow this function rule. So it's kind of just a recursive rule, but it's written as a function. Can you pay attention, please? Thanks. Okay, so to find x1, we'll just do 4 times the term right before it, and then subtract 3. So 4 times the term right before it, subtract 3 to get 5. To find x2, again, we'll just do 4 times the term right before it and subtract 3, which would be minus 3, which would be 17. Okay, and then the last one, again, 4 times the number right before it, and then subtract 3, which would be 65. So these are the first 3 iterates. So it just means it's very recursive rule feeling.